Right. It is said that we have not discussed questions of 600 questions Tute, question number 6 to 10. First of all, let's complete them. But it's better if you use some separate papers to write those answers or in a separate book. Right. Because this is not directly related to the Tute. Sorry, theory not. So therefore, it's better to use a separate one. And let's complete question number 6 to 10 first of all. Right, so we have started linear motion. Actually, we are at the end of linear motion. So within 2 weeks, the linear motion section will be over. We'll be able to start circular and rotational motion. But unfortunately, we have forgotten to discuss these 5 questions, 6 to 10. So let's give a try. Right, what's the first question? Somebody please read question number 6, dear. Somebody in the class, please read.
A van starts to move with a velocity of 25 kilometers per hour along a straight road with a constant acceleration. Its velocity becomes 35 kilometers per hour after it travels a distance of 30 kilometers. Calculate the time taken for the motion. Find the acceleration.
Okay, thank you very much, dear. So, van starts to move with the velocity of 25 kilometer per hour. Final velocity 35 kilometer per hour. Distance 30 kilometers. So all the things are given in kilometers. Therefore, it's better to keep the units as kilometers and hours. Then that will be much easier. If we keep the units as kilometer and kilometer per hour, that will be much easier to solve this problem. So I'll try to quickly discuss these questions because we should start a new theory part. Right. So how to do it? Right, let's use this whiteboard. That's much easier. Let's use the whiteboard and mark the given data. So this is 600 questions Tute. Right, we are going to discuss question number 6. It tells us a van travels with a certain velocity. A van travels with a certain velocity. A certain acceleration actually. Right? A van travels with a certain acceleration. Acceleration is not given as I think. I think acceleration is not given. Right. Would you please draw the figure with me, dear? Please draw the figure with me. Right, initial velocity as I remember it is given as 25 kilometer per hour. Initial velocity is given as 25 kilometer per hour. Please check whether this is correct here. Initial velocity is 25 kilometer per hour. After some time, the velocity is given as, final velocity is given as 30 kilometer per hour. 30 kilometer per hour. These are the given data. And what about the distance traveled by the object here? Somebody? Lamai, what is the distance traveled by the object?
35 kilometers per hour.
30 or 35?
35.
35 kilometer. So
Oh,
here
sir,
I have
final velocity is 35 kilometers per hour.
5 kilometers per hour.
final velocity 35, distance traveled is 25, right?
Distance is 30 kilometers.
Distance is 30 kilometer. Yeah. Distance is 30, final velocity 35, right? Yeah. This is 35. Time is not given. We have to find the time. Right. So let me mark the time taken for the motion as simple t hours. Normally we mark the time in seconds. Here let me mark the time as hours. Then that will be much easier. So time taken for the motion is capital T hours. Acceleration we don't know. Acceleration we don't know. So here let me take acceleration as simple A, but the unit is, normally we write meters per square second. Here it should be kilometer per square hour, not square seconds, square hour. Can you understand? So those are the data. Quick dear, draw the figure. Initial velocity 25 kilometer per hour. Final velocity 35 kilometer per hour. Acceleration simple A, kilometer per square hours. Distance travel 30 kilometer and time taken T hours. Okay, right. Now we want to find the acceleration as well as time. Please tell me once you draw the figure. After that, I'll continue. Right, here they have not given us time. So as time is not given, we should not use the equations with the term simple t. So therefore the best thing to use equation without the term time. So that is v square. That is v square equals u square plus 2as. So this is the best equation when time is not given. So final velocity is given as 35. So we have to get square of 35 equals u is 25. We should get square of 25 plus 2 into a. We don't know. A into s, we know 30 kilometers. S is 30 kilometers. We should not get the square of 35 and square of 25 because there are some other easier method to simplify here. Actually, there are some many other methods to simplify without getting the square terms. Let me show you one method here. So I don't do anything to 35 square. I'll keep 35 square as it is. But I'll take positive 25 square to this side. So then it will be minus 25 square. Minus 25 square. Got it? And the other side, the remaining terms will be 2 into a into 2 into a into 30. 2 into a into 30. That will be the remaining terms. Right? So after that, we know that in O levels, I think you may remember this. Check whether you remember this from O levels. O level max. Do you remember that x square minus y square equals, do you remember this? Somebody? Lamai? Hello?
Yes, sir.
Yes, dear?
X minus y, x plus y.
Very good. X plus y into x minus y. So this is, you have learned this in O level. So I'm going to use the same thing here. Right? So here I'll take 35 as x. So it should be x plus y. 35 plus y means 25. Into x 35 minus y 25. Like that. Equals 2 into a into s. So 35 plus 25, 35 plus 5, 40 plus 2, 60. 60 into 35 minus 25 is 10 equals 2 into a, sorry, s is 30. Sorry, s is 30. So 2 times 30 is 60. 2 times 30 is 60 times a. Now you should understand that this 60 and this 60 cancelled out. 60 from this side to 60 from other side cancelled out. Finally, we will get that acceleration equals only 10 will be there, 60 cancelled out. But please very much be careful to mark unit as 10 kilometer per square hours. Who got this answer at home, dear? Anybody in the class? Lamai? And please write down this note also. Write down note also quick. Right, now we know the acceleration. Now we can find the time taken easily. So let's try to find the time taken. To find the time taken, now we can use the equation V equals U plus 80. Final velocity is 35. Initial velocity is 25. Acceleration is 10. Time is simple t, but please remember that time is in hours, not in seconds. So 35 plus 25 come to this side as minus 25 equals 10 times t. 10 times t. So 35 minus 25 is 10 equals 10 equals 10t. So what do you think about what should be the next step here? This 10 and 10 cancelled out. Is answer 0? No, 10 divided by 10 is 1. Therefore, the time taken is 1. But what is the unit? Somebody please tell me the unit here. Lamai, what should be the unit?
Hours.
1 hour. Very good. So time taken is 1. Unit is hour. Please complete it here. 1 hour. Right, I think time is enough. Shall we go to question number 7, dear? Who wants more time to write the things? Shall we go to question number 6? Please give me the permission.
Okay, sir.
Somebody please read question number 7. Somebody please read question number 7, quick.
A car starts to move at rest. It travels first 10 seconds with a constant acceleration of 2 meters per second, and the next 1 minute with the obtained constant velocity during the final 30 seconds. It decelerates with a constant rate and comes to rest. Find the average velocity of the car.
Right, thank you, dear. So it tells us a car starts to move at rest. It travels first 10 seconds with a constant acceleration of 2 meters per square seconds. The next 1 minute with a constant velocity. During the final 30 seconds, it travels with a constant rate and comes to rest. So it means there is acceleration, constant velocity, even deceleration. Find the average velocity of the car. Find the average velocity of the car. So let's give a try here. Right. Question number 6. So now this is not question number 7. It is, sorry, it's question number 7. Now it is not a van but a car, but I'm not going to change the drawing. I'll keep as it is. Okay, dear. I'll keep the car also in the shape of a van. Right. So initially the car starts to move at rest. The car starts to move at rest. It accelerates and velocity increases to a certain value. So initial velocity here is 0. Unit is meters per second. Right? It accelerates. Let me mark the acceleration as A1. I don't remember whether A1 is given or not. Okay, dear? So after that, the vehicle travels with a constant velocity. For a certain time period, it travels with a constant velocity. So we don't know this velocity. So let me mark this velocity as V1 meter per second. Got it, dear? Right. Please draw the figure with me, dear. It travels with this constant velocity for a certain time period. I don't remember the time period. And then it decelerates and finally it comes to rest. Okay, dear? Draw the figure with me, dear, quick. So as it travels, let's say starting point as capital A, it starts its motion at the point capital A, right? A to B, it travels with a constant acceleration of A1. Let's check later whether A1 is given or not, right? The distance traveled, then B to C travels with a constant velocity. So you should know that when the velocity is constant, acceleration is 0. C to D travels with a deceleration and finally it comes to rest. Clear? Did you draw the figure, dear? Can you hear me, Lamai? Lamai, can you hear me?
Yes, sir.
Yes, sir.
Yeah. Right. Draw the figure quick. So B to C, there is no change in velocity. Therefore, even at the point C, velocity will be V1. Meter per second, not meter per square seconds, meter per second. And C2, when it reaches to D, velocity will be 0. Velocity will be 0. Right? So those are the given data. Here, time is T1. Now it is not hours, but it is now seconds. Seconds. This displacement is S1. I don't know whether S1 is given or not. Let's check and mark the data. If S1 is given, we can mark it. If S1 is not given, it's okay. Let's try to find it. Right. B to C displacement. Let's take it as S2. I don't know whether it is given or not. B to C time taken. Let's take simple T2. I don't know whether it is given or not. I don't care whether it is given or not because I can handle it. I can find. If T2 is not given, I can find it. So I don't care. I don't worry about S1. So this displacement is S3. Let's check whether it is given in the question or not. Please draw the figure quickly, dear. Once you draw the figure, please tell me, right? So here times taken as seconds. T1 seconds, T2 seconds, and T3 seconds. The unit of time is seconds, right? Right. Complete it, dear. Please tell me once you draw the figure, okay?
Okay, sir.
Now, somebody please tell me whether S1 is given or not.
Not given.
S1 is not given, right? What about S2 then?
No, sir.
Let me read the question once again. I took it to the board. A car starts to move at rest. It travels its first 10 seconds. T1 is given. What is T1 here? T1 is 10 seconds. T1 is 10 seconds. It travels its first 10 seconds with a constant acceleration of 2 meters per square seconds. So it means this acceleration is given 2 meters per square seconds. That is given. This is S-1, right? Right. So let me read the question and let's mark the given data. A car starts to move at rest. It travels first 10 seconds with a constant acceleration of 2 meters per square seconds. And the next 1 minute travels with the obtained constant velocity. 1 minute means, next 1 minute means, 1 minute means, how many seconds, dear? 60 seconds. So T2 is also given. T2 given. Right. Then let me read the next part of the question. During the final 30 seconds, it decelerates with a constant rate and comes to rest. Final 30 seconds means T3. So they have given T3 as 30 seconds. So T1, T2, T3 given. Actually, it's so simple. We just want to find T2, S1, S2, S3. That's it. So I have marked all the given data. And here they have not given us the CD deceleration, not given. They have not given this CD deceleration. That's the only upset thing here. This one. So let me mark it as A3. That is not given. A3 not given. All the other data are given. Okay, please complete the figures with all the data. Please complete the figures with the data here, quick. Once you complete the figures, please tell me.
Okay, sir.
Okay, sir.
Okay, so what should we do next? What should we do next here? Let's try to find S1, S2, S3. So look at board carefully. Look at board very carefully. I'll apply this equation from capital A to capital B. I should indicate the section that I apply the equation. And I apply the equation S equals UT plus half AT square. I apply this equation. S is S1 equals U is 0 because starts motion at rest. Time is 10 seconds plus half, please write with me, half into A1, that is 2, into time, that is 10, we should get the square of 10. Check there. So I have applied the equation S equal UT plus half AT square from A to B. My target is to find S1, right? I'm going to find S1. 0 into anything is 0. Plus, you should understand that this 2 and this 2 cancelled out. You see, the 2 in half and acceleration 2, these two are cancelled out. You will get only 1 into 10 square. You will get only 1 into 10 square. So what is 10 square here? Somebody please tell me. Lamai, unmute the mic and tell me what the 10 square is.
100.
Yeah, 100 meters. So S1 is 100 meter. Complete it here. Is complete. S1 is 100 meter. So to find S1, A to B, we have applied S equal UT plus half AT square. Actually, we want to find V1 also. So what should we do to find V1? Somebody unmute the mic and tell me. What should we do to find V1? Lamai? Darwane, what should we do to find V1?
Apply the equation V equals U plus AT.
Very good. Where to where, dear?
From A to B.
Very good. Let's apply S equal. Very good. Let's apply S equal UT plus half AT. Sorry, V equals U plus AT from A to B. Then we can find the velocity V1. Let's do it. A to B. A to B. Let's apply V equals U plus AT. So velocity at the point B, that is V1, that's what we want to find. Initial velocity is the velocity at A, that is 0, plus acceleration is given as 2, time taken is given as 10. So 2 plus 10 is 20, 20 plus 0 is 20. So V1 is found as 20 meters per second. Who got this answer earlier than me? Anybody in the class? Very good. So we have applied V equals U plus AT from A to B. In this kind of questions, it's must to indicate the section of the equation, the section that you apply the equation. Got it here? If you do not indicate the section, most probably you will not earn marks. So please clearly indicate the section to which that you apply the equation. Right. What do you think about B to C motion, dear? B to C, the object moves with a constant velocity. If the velocity is constant, if an object is moving with a constant velocity, we can apply this equation. I think you remember this, right? The object moves with a constant velocity, from B to C. So therefore, the following equation can be applied. So what's the equation that we applied for constant velocity here? Lamai? You don't remember. If the velocity is constant, we can apply the equation velocity equals displacement divided by time taken. Do you remember this or not? Right? So velocity from B to C is V1. Displacement. Velocity from B to C is V1. Displacement from B to C is S2. Time taken is T2. Can you do the rest and find this S2 dear? Lamai? Are you there with me? Are you with
Yes,
me
sir.
or not? Can you do the rest and find the displacement S2? Can you hear me?
Yes.
Yes, sir.
Thank you, dear. When I use this whiteboard method, screen sharing method, it's very difficult to read your Zoom messages. So best thing is unmute the mic and talk to me directly. Okay, dear. So please unmute the mic and directly talk to me when you have a doubt or when you want to say something, because it's somewhat difficult to read messages while we are using screen sharing method. By cross multiplication, T2 can be taken to this side. So dividing T2 comes this side as multiplication T2, and S2 will be there at the other side, right? So division becomes multiplication when it comes to the other side, right? Now we just want to find S2, right? V1 is given as, we have found V1 as 20. T2 is given as 60 equals S2. Right? So what should be the answer? 2 times 60 is 12 and 00 will be there. So then S2 will be equal to 1200 meter. Am I right here? Who got this answer earlier than me? So S2 is 1200 meter. So what's the next thing that should be found here? What's the next thing here? We should find S3. We should find S3. That's what we want to find next. So what's the equation that should be applied to find S3? Somebody? Lamai? Suggest me an equation to find S3. Can we find S3 directly or not? Can we find S3 directly or not? I think you know the logic. When you can't, very good. We cannot find S3 directly. First of all, we have to find the acceleration. Here actually not the acceleration, but a deceleration. Therefore, C to D, we have to apply the equation V equals U plus AT to find the acceleration. Final velocity is 0. Initial velocity is V1. C to D I am applying. As I am applying the equation from C to D, initial velocity is V1. Final velocity is 0. Right? V1 is the initial velocity. Plus acceleration is A3. That's what we want to find, A3. Time is T3. Can you do the rest and find the velocity, acceleration A3, dear? Please try to do the rest and find the acceleration A3.
Okay, sir.
Lavai, can you see the board clearly? This division, this multiplication 30 goes to the other side as division 30. Multiplication 30 goes to the other side as division 30. So A3 equal minus 20 divided by 30. So 0, 0 cancelled out. Then what will be the acceleration here? Actually, you will get the acceleration with the minus sign. Can you see the board clearly? Or is there any black window? It will be minus zeros cancelled out, minus 2 over 3. So is it acceleration or a deceleration? Somebody please tell me.
Deceleration.
It's a deceleration. Why?
It has a minus value.
Because there is a minus sign. So we have found the acceleration from B to C as minus 2 over 3. So acceleration is minus, means it's a deceleration. It's a deceleration. Okay. Right. What should we do next, dear? What should we do next? What are things that we have already found here? We have found that S1 equals 100 meter. Then we have found that S2 equals 1200 meter. Then we have found, we should find S3. So next one should be the value of S3. So what should we do to find S3, dear? Somebody please tell me. What should we do to find S3?
Apply the equation S equals ut plus half at square.
Very good, very good. To find S3, we should apply this equation C to D. C to D, we should apply S equal ut plus half at square. C to D displacement is S3. Velocity at C is V1. U is V1. Time taken is 30 seconds plus half. Acceleration is A3. Time taken is 30 seconds. We should get the square of it. We should get the square of it. Can you do the rest and find S3, dear? Write this equation and try to find S3. Give a try. Give a try to find S3 quick. We know that V1 is 20. V1 is 20. Should be multiplied by the time taken T3 30. Plus nothing will happen to this half into acceleration A3. We have found it as minus 2/3 into 30 square is 900. 30 square is 900. 20 times 30, 2 times 3 is 600. Now you should understand this plus sign and this minus sign. The plus sign into the minus sign is minus 600 minus. And you should understand this denominator 2 and this 2 cancelled out. Can you see it here? This 2 and this 2 cancelled out. And finally, there will be 1/3 because number 2 cancelled out into 900. Is it clear here? 2 terms cancelled out. 2 and 2 cancelled out. Right. So then we will get 600 minus 900 divided by 3 is 300. 600 minus 300 is 300. So what is S3 here? Lamai, please tell me what the S3 is. Can you see it clearly? What is S3? Lamai, what is S3? How many meters?
300.
300 meter. Very good. Very good. Who got this answer earlier than me? Right. Please write them all. Tell me once you have written them all. Please tell me once you have written them all.
Okay, sir.
Right. I'll erase all the things that I have written because I want some more space to write the things. Do you remember the average displacement equation? Sorry, average velocity equation here. Do you remember what the average velocity equation?
Total displacement divided by total time.
Very good. Average velocity equals to total displacement divided by total time taken. Right, so let's apply that equation. Please write with me, don't wait. Average velocity equals total displacement divided by total time taken. Please write with me, dear. Right? So total displacement means S1 plus S2 plus S3 divided by total time taken means T1 plus T2 plus T3. Can you do the rest without my help, dear? Lamai, can you do the rest without my help and find average velocity?
Okay, sir.
So S1, we have found S1 as 100 meter plus S2 as 1200 meter plus S3 as 300 meter, right? Divided by T1, 10 seconds, plus T2, 1 minute, it means 60 seconds, T3, 30 seconds. Then what will happen here? So then 100 plus 100 plus 1200, 1300 plus 300 means 1600. Divided by 10 plus 60, 70 plus 30, 100. So it means two zeros will be cancelled out. Average velocity will be 16 meter per second. Who got this answer earlier than me? Anybody in the class? Very good. So please remember this procedure, right? Please write them all and tell me. Once you have written them all, please tell me, then I'll go to the next question.
Okay, sir.
So let's go to the next question. Let's go to next question. So we have completed question number 7. We should discuss now 8, 9, and 10. Okay, somebody please unmute the mic and read question number 8. Somebody unmute the mic and read question number 8. Start.
A vehicle travels along a straight road. It travels first d-meter distance with a constant velocity of u meters per second and next d-meter distance with a constant velocity of v meters per second. Final d-meter distance is traveled with a constant velocity of w meters per second. Obtain an expression for its average velocity.
Actually, it's very similar to the previous question, but no acceleration, but almost very similar to the previous one. A vehicle travels along a straight road. It travels for a simple d meter with the constant velocity of u meter per second. The next simple d meter distance travels with the constant velocity of v meter per second. Final d meter distance travels with the velocity of w meter per second. Obtain an expression for its average velocity. Obtain an expression for its average velocity. So let's give a try. Let's give a try here. Actually, we are able to use the same diagram here. It's very easy to edit this one. Now this is question number not 7. It is question number 8. No accelerations. That moving with constant velocities mean no accelerations. That's the first point you should understand. No accelerations. Let me show you the things properly. Wait. I don't want this equation. I'll keep it somewhere else, and I'll keep this also somewhere else like this. Right. Now things are clear. The first simple d meter travels with a constant velocity of u meter per second. That's what they have said. U meter per second. Not square seconds, but seconds. So the vehicle travels from A to B with a constant velocity. The vehicle travels from A to B with a constant velocity of u meter per second. The distance from A to B is 1. Time taken for the object to travel from A to B, t1 seconds. We don't know what the t1 is. That's the story. Similarly, B to C distance is simple d meter, and we don't know the time taken for the object to travel from B to C. So let me take the time taken for the object to travel from B to C as t2 seconds. T2 seconds. Got it, dear? T2 seconds. Right. So similarly, the distance traveled by the object from C to D is simple d meter, and time taken for the object travel from C to D, let me take it as simple t3 seconds. Could you please draw the figure here? Everybody please draw this figure. And velocity of the object when it travels from C to D. Velocity of the object when it travels from C to D is given as W meter per second. Meter per second, not meter per square seconds. So actually they have given a lot of data. We just want to simplify these equations. We should substitute these values in the equations to find the answers. Right? A to B velocity D u meter per second, and B to C velocity we should mark. B to C velocity we should mark. Let's mark that velocity as, I think it's given as v meter per second. B to C velocity is v meter per second. B to C velocity is V meter per second. Mark them all here. Mark them all, complete the figure and tell me. Who wants more time? Draw the figure here. If you have complete drawn the figure, please tell me.
Okay, sir.
Right, let's give a try. So what do you think about the motions, dear? Are there any accelerations, dear? Are there any accelerations? There are no accelerations. So that's the main point. So please write. As the object, please write. As the object always move with constant velocities, comma, the following equation can be applied. What's the equation, dear? The object always moving with the constant velocity. So therefore, we can apply the constant velocity equation. What is it? Velocity equals displacement divided by time taken. So we can apply this equation because object always move with constant velocities. Okay, dear? Right, actually here they have given velocity and displacement. The only thing we want to find is the time. So I'll do something like this. I'll take time taken to the other side I'll take time taken to this side and velocity to the other side by using cross multiplication. That's what I am going to do. Okay, dear? Right. So I'll change the terms velocity and time taken. I'm going to interchange the terms velocity and time taken. Then we will get something like this. Time taken equals displacement divided by velocity. Can you understand it here? And let me mark this equation as equation X. We have to put a certain letter, then it will be much easier. Write them all here, quick. So I would like to mark this as my equation. I'll let me use the term X. So this is my equation X, and I'm going to use equation X from A to B, B to C, and C to D. That's what I'm going to do. Okay. So what am I going to do here? I'm going to use equation X from A to B, B to C, and C to D. So write them all and tell me.
Okay, sir.
Right, so let's use equation X from B to C. Let's use equation X from B to C. Equation X from, sorry, A to B. A to B. Right, equation X tells us time taken. Time taken is T1 equals displacement is S1 divided by velocity is V. Okay, dear? So T1 equals S1 is given as simple D divided by V. Okay, complete, dear? And let's mark this as our equation number 1. So I have applied the equation X from A to B. And now I'm going to mark it as my equation number 1. Right, similarly, we are going to apply equation X Similarly, we are going to apply equation X from B to C, right? Equation X tells us time taken, you see here. Equation X tells us time taken equals displacement divided by time taken. Displacement divided by velocity. Time taken equal displacement divided by velocity. So let me use it. Time taken is T2. Displacement is S2 divided by velocity is V. Velocity is V. So T2 equals S2 is given as simple T divided by V. And let me take this as my equation number 2. Complete here. Write them all. Let me mark this as equation number 2. Please tell me once you have written them all, okay?
Okay, sir.
Right, you said that you have written. So if so, let's apply the same equation. Let's apply the same equation X from B to C. From not B to C, C to D, ne? C to D. Okay, Lamai. Equation X tells us time taken T3 equals displacement S3 divided by velocity that's given as W. So T3 equals S3 displacement is given as D, velocity is W, and let me mark this as my third equation. Let me mark this as my third equation. Start there. Write them and tell me once you have written them, okay? Who wants more time to write the things, dear? Lamai, do you want any more time?
No, sir.
Okay, if so, let's continue. So this is equation next. So I have edited it. And this is equation number 1. Equation number 1. Are you all able to see the things that I have written on the board here? Is board clear for all of you? Lamai?
Yes, sir.
Right. Thank you, dear. So this is equation number 2. Equation number 2. This is equation number 3. This is equation number 3. Now I'm going to apply this equation to find the average velocity. So ready-made equation is there because already we have used this. So what is average velocity here? Average velocity equal total displacement divided by total time taken. Please apply this equation and try to solve the problem. Give a try here. Lamai, please give a try. Write the average velocity equation and try to solve the problem. Lamai, there's a small mistake in the first equation. Lamai, in the first equation, velocity from A to B is U. A to B is U. Please correct it here. Velocity in the first equation, A to B velocity is U, B to C velocity V, C to D velocity W. So it was mistakenly I have written it as V should be U. Please correct that mistake. Sorry. There is another thing that I would like to tell you. It will be much easier. Look at here. It will be easier if we find the total time taken separately. I don't know whether it's how it is for you. If we find total time taken separately, I think that will be much easier. T1 plus T2 plus T3. So T1 is D over U. simple D divided by simple U. T2 is simple D divided by V. Wait. Then T3 is simple D divided by W. Okay, dear? So total time taken, let me take total time taken as capital T. If you check the answer, the easiest method to simplify this kind of equation is multiplying all the terms by U, V, W. Just look at board here. Just look at board. U, V, W. I multiply all the terms by U, V, W. So here, this D over U multiplied by U, V, W. And similarly, this D over V multiplied by U, V, W. Got it? So similarly, the last term, the final term, D over W, right? That should also be multiplied by UVW. This is also multiplied by UVW. Please check this method here. If you follow this method, I think it will be much easier for the simplifications. So once all the terms are multiplied like this, right? This side, this T over term will not be changed. There will not be any change in this term. T into UVW, no change. What about the other terms, dear? Huh? What about the other terms? Lamai? UVW not changed. What do you think about this U terms here? Denominator U and this U, what will happen to them? You have to talk to me. I think you know the rule. If you are silent, I will also be silent.
It will cancel down.
Yes, very good. They are cancelled out. So what are the remaining terms here?
V and W.
V and W. D into VW remaining. In the other term, what will happen here? This term. This denominator V and this V will be cancelled out. Am I right? Lamai? What's the term that cancelled out in the next step here? Here.
V
cancelled out. So what are the remaining terms?
U and W.
U and W remaining. In the next term, what the letter? Which letter will cancel out?
W.
W will cancel out. So what are the remaining terms, dear?
U and V.
What are the remaining terms?
U and V.
U and V remaining. So again, nothing will happen to this T times UVW. T times UVW not changed. It's not changed. T times UVW not changed. But if you consider the other side, you see simple D and this simple D and this simple D. What do you think about them, dear? Simple D, Simple D, common. Therefore, simple D can be taken out from a bracket. So what are the remaining terms, dear? Somebody please tell me what are the remaining terms inside the bracket?
UVW.
A, from here or from all the three terms, D is taken out, remaining terms VW. Then plus D is taken out. So what is the remaining? What are the remaining terms, dear?
UW.
UW. Right. Similarly, D is taken out. So what are the remaining terms, dear? What are the remaining terms?
UV.
UV. Got it? So in the next step, actually, we use cross multiplication and we'll take UVW to the other side. Then capital T can be subjected. Capital T can be subjected. Okay. So in the next step, by using cross multiplication, we take the other term. This term will not be changed. This term will not be changed, and we take that product multiplication UVW come to the other side as division UVW. Right? The terms inside the brackets will not be changed. Start there. Please write them. I think if you subject the total time taken like this, that will be much easier to obtain the answer. Complete it here. Complete it. And mark this as your fourth equation. I think that's much easier. The simplifications will be much easier if you obtain an expression for the total time taken like this. Write them there quick.
Okay, sir.
Tamai, shall we continue, Darwane? Kids, are you ready? Where are my kids? Hello, can you hear me?
Yes, sir.
So let's keep this equation somewhere else, otherwise it will be difficult. Right. So let's keep this equation here and let's give a try to find the average velocity. I have to manage this available space. Now we have space, yeah. So now we know the total time taken. We just want to find an expression for the average velocity. Average velocity equal total displacement divided by total time taken. Total displacement is S1 plus S2 plus S3. S1 is simple D. S2 is simple D. S3 is also simple D. Divided by total time taken. For the total time taken, I have taken the letter capital T. Capital T. Right? So, wait. D plus D plus D, that is 3D. 3 times D. Divided by what is capital T here? What is capital T here? Can you do the rest? Lamai, can you see the board clearly? You would try to do the rest and obtain the answer, please. T, we have found capital T as simple D divided by, sorry, simple, wait, not divided, simple D times VW plus UW plus UV. Everything divided by UVW. So this is the total time taken. Total time taken is obtained as D times VW plus UW plus UV divided by UVW. So how to simplify this here? Lamai, please give me a minute. Can you hear me, dear? Hello, can you hear me? Let's write the rest of the steps in the board here because it will be difficult to use the virtual board. Let's use a real whiteboard and simplify the rest of the steps. Okay, dear? Lamai, can you hear me? Right, we were trying to find the average velocity. We have obtained an equation for the average velocity like this. As I remember, 3d divided by d times, few terms were inside the brackets, divided by UVW. Am I right here? Somebody please tell me the terms inside this bracket. Unmute the mic and tell me the terms inside this bracket. Quick.
UW plus VW plus
VW plus
UV.
I prefer to use this real whiteboard for this. This division becomes multiplication when you get the reciprocal. So it means the term UVW go up and the other terms comes to the denominator side. UW plus VW plus UV. Now you see, the beauty is we can cancel out the common term. We can cancel out this common term simple d. Simple d will be cancelled out. The remaining terms, this 3 will be multiplied with UVW. So it will be 3 UVW divided by UW plus VW plus UV. So this is the final answer. This is the average velocity of this motion. Average velocity of this motion. Completely quick. Just tell me once you have written them all, okay?
Okay, sir.
Shall we go to the next question, Lamai? Question number 9.
Okay, sir.
Right, so let's go to question number 9. Okay, somebody unmute the mic and read question number 9. Somebody please unmute the mic and read question number 9. Start.
A box is at rest on a rough horizontal ground. A boy hits the box and then it starts to move on the ground with a velocity of 10 meters per second. Due to the friction, the box moves with a constant deceleration and comes to rest. After traveling a distance of 12.5 meters, Calculate its deceleration.
Okay, thank you, dear. A box is at rest on a rough horizontal ground. A boy hits the box and then it starts to move on the ground with a velocity of 10 meters per second due to the friction. So 10 meters per second, full stop. Due to the friction, the box moves with a constant deceleration and comes to rest. Due to the friction, the box moves with a constant deceleration and comes to rest. After traveling a distance of 12.5 meters, the box comes to rest after traveling a distance of 12.5 meters. Calculate its deceleration. Starting velocity is 10 meters per second. The distance traveled 12.5 meters. Final velocity is 0, comes to rest. So we should find the deceleration. I think it's not such a big case. Let's give a try. Question number 9 of 600 questions Tute. Question number 9 of 600 questions Tute. Let me draw a figure. Let me draw a simple figure. There is a box. A boy kicks it. A boy kicks the box. So it starts to move with a velocity of 10 meters per second. It travels with a certain deceleration. And finally it comes to rest. The velocity of the box is reduced because of the friction force given by the surface. So let me mark the friction force as Fr Newton. F friction. Right? So the question asks us to find the deceleration. Let me mark it as an acceleration. Let's mark this as an acceleration. Once we find the value of the acceleration, if the acceleration with the minus sign, so we are so sure that it's not the acceleration, it's a deceleration. Draw it here. Draw the figure and mark the displacement. The distance traveled by the object is given as 12.5 meters. Draw the figure here. Draw the figure and mark the given data. Start.
Okay, sir.
Right. Let's continue here. What should we do to find the deceleration? Can somebody give me a method? Lamai? What's the equation that should be applied to find the deceleration?
V squared equals U squared plus 2AS.
Sorry, I didn't hear you. Lamai?
V squared equals U squared plus 2AS.
Very good, very good. We should apply V square equals U square plus 2AS. Our final velocity is 0. Initial velocity is 10 plus 2. We don't know what the acceleration is. Displacement is given as 12.5. 0 equals square of 10 is 100. Plus 12 times 2 times 12.5 is 25 times 8. 12.5 times 2 is 25. Plus 25 will come this side as minus 25 times A equals 100. Therefore, A equals 100 divided by minus 25. If you divide 100 by 25, answer is 4. The minus sign will be there. A equal minus 4 meter per square seconds. I want to tell you something about the minus sign and the other things. First of all, please write. After that, I'll explain. Start. Right. If you use the term acceleration, then it should be written with the minus sign. Acceleration equals minus 4 meter per square seconds. But if you want to say deceleration, deceleration is, that's the point, plus 4 meter per square seconds. Can you understand it? In all the linear motion equations such as V equal U plus AT, V square equals U square plus 2AS, S equal UT plus half AT square, A is acceleration. So we have found A, it means we have found acceleration. So acceleration equals minus 4 meter per square seconds. But if you use the term deceleration is positive 4. Got it? But normally we don't write the plus sign, we just say deceleration is 4. Complete here. And if you have any further doubt about this acceleration, deceleration, and positive negative signs, please ask. I can help you. Start there, quick. Okay, shall we go to question number 10? Lamai, shall we go to question number 10? Who wants more time to write? Please give me your permission to go to question number 10, quick.
Okay, sir.
Can you see question number 10, dear? Amai, can you see question number 10? Can somebody read question number 10? Somebody please unmute the mic and read question number 10, please.
When a car is at rest at a straight road, a van passes it with a velocity of 12 meters per second. The car starts to move with a constant acceleration of 0.3 meters per square second. At the time when the van passes the car, how long does it take for the car to overtake the van? Find the velocity of the car when it overtakes the van.
Right. Can you understand the story here? When a car is at rest at a straight road, a van passes it with a velocity of 12 meters per second. The car starts to move with a constant acceleration of 0.3 meters per square seconds at the time when the van passes the car. Right. Van is moving with a constant velocity of 12. Car is moving with an acceleration of 0.3 meters per square seconds. Right? So, somebody please tell me what will happen to the velocity of the car with the time. Will the velocity of the car increase with the time or decrease with the time? Somebody please tell me what will happen to the velocity of the car with the time. Will it be increased with the time or will it be decreased with the time?
Increase.
It will increase with the time. So if you want any more time to write these things, please take a screenshot. If you want any more time to write the things, please take a screenshot. I'm going to erase the board. I'm going to erase the board. Right. Look at board carefully. Okay. So let me use this point as the starting point. We are going to discuss question number 10. So there is a car, it is at rest at this red color line. The car is at rest at this red color line initially. At the same time, a van comes with a velocity of 12 meters per second. Right? So the car starts to move with the velocity of 0. At that time, the van passes the car with the velocity of 12. So let me take the starting point as x. Got it? So initially, this is the initial situation. Initially, the van has a larger velocity. Van has a larger velocity than the car. So van will overtake. The van will overtake. And with the time, we can observe that my red pen is the car moving with the increasing velocity like this. So finally, the van and car will reach to the same point, something like this. So let me mark this as y. Let me explain again. Imagine my red pen is the car, my black pen is the van. Initially, van has a larger velocity, so it will be leading. The car will slowly move, but increasing with the velocity. So car moving with an increasing velocity like this, and both van and the car reach to the point Y at the same time. But at that time, the most important thing is the car definitely has a larger velocity than the van. So let me mark the velocity of the car as V1 meter per second. And let me mark the velocity of the van as V2 meter per second. Right. Distance from X to Y. Distance from X to Y. Let me take this as simple d meter. My question, I'm going to ask you a question before you draw this. For example, let's think this X is Gampaha. Right? And Y is, let's imagine that is Colombo. Right? So, van and car starts at Gampaha. Let's imagine that there's a straight road from Gampaha to Colombo. Let's imagine. Both of them start to move at 10 a.m. in the morning. 10 a.m. in the morning. Car starts at rest and it travels with a certain acceleration. Here, as I remember, the acceleration is given as 0.3 meter per square seconds. Van moves with the constant velocity, car moves with the constant acceleration. Both of them, the car and the van, both of them reach to Colombo at 12 noon. Clear? When they reach to Colombo, velocity of the car is V1 meter per second, velocity of the van V2, but we know that the velocity V2 is equal to 12 meter per second because van moves with the constant velocity. Now my question is, how long does it take for the van to travel from Gampaha to Colombo? Somebody please unmute the mic and tell me. Just look at the figure and tell me the time taken for the van to travel from Gampaha to Colombo. How many hours?
2 hours.
2 hours. Very good. 2 hours. Very good. Similarly, somebody please unmute the mic and tell me the time taken for the car to travel from Gampaha to Colombo. How long does it take for the car to travel from Gampaha to Colombo?
2 hours.
Sorry, I didn't hear you. Lamai? That is also 2 hours. Both start at Gampaha at 10 a.m. Both reach to Colombo at 12 noon. So 10 to 12, 2 hours. Therefore, the time taken for the car to travel from Gampaha to Colombo, 2 hours. The time taken for the van to travel from Gampaha to Colombo, 2 hours. Therefore, time taken for both vehicles to travel from X to Y should be the same. Let me mark it as 3 seconds. Both vehicles travel the same d meter distance within the same time duration of simple 8 seconds. But there is a difference that van travels with the constant velocity and the car travels with the constant acceleration. But they start at the same point at the same time. They reach to the same point at the same time. They have traveled the same distance within the same time durations. One is with the constant velocity, the other one with the constant acceleration. Draw the figure, but here no need to mark Gampaha and Colombo. I just use them to explain you, but X and Y needed. So just draw the figure and tell me once you have completely drawn it. After that, let's go to the discussion. Start.
Okay, sir.
Shall we continue, dear? Is the time enough? Who wants more time to draw the figure? Lamai? Do you want any more time?
No, sir.
No. So please write a small description. Please write a small description. Both vehicles start their motion at X. Both vehicles start their motions at X. And both vehicles start their motions at X. And both of them reach to Y at the same time. Both vehicles start their motions at X, and both of them reach to Y at the same time. Both vehicles start their motions at X, and both of them reach to Y at the same time. Both of them reach to Y at the same time. Full stop. Therefore, the time taken for both of the vehicles to travel from X to Y. Therefore, the time taken for both vehicles to travel from X to Y, is the same. Therefore, the time taken for both vehicles to travel from X to Y is same. Right? So, time taken for the car is simple t seconds. Time taken for the van is also simple t seconds. They are not like T1, T2. They are not T1, T2. They simple T, simple T. Somebody unmute the mic and read that note again loudly. Somebody unmute the mic and read that note loudly. I would like to hear.
Both vehicles start their motion at X and both of them reach to Y at the same time. Therefore, time taken for both of the vehicles to travel from X to Y is same.
Thank you, Ria. Thank you very much. Should I explain that they have taken the same time to travel from X to Y? Or are you okay with the explanation? Would like if I explain it again? Anybody in the class? Right? If so, if you have any doubt, just ask me. So please write, as the van is moving with a constant velocity, the following equation can be applied. As the van is moving with a constant velocity, comma, the following equation can be applied. As the van is moving with a constant velocity, comma, the following equation can be applied. Look at what we can apply the equation. Velocity equals displacement divided by time taken. Velocity of the van is 12. Is it correct here? Displacement is simple d, time taken is t. If I use cross multiplication, I'll get 12. I'll subject simple d. 12 times t equals simple d. Let me take this as my first equation. So I have applied the equation velocity equal displacement divided by time taken for the van, because van is moving with a constant velocity. So this is the equation that we use to find constant velocity and average velocity. So velocity is 12 equal displacement d time taken t, d divided by t, t is taken to the other side, then we get 12 times t equals d. Equation number 1. Complete here.
Okay, sir.
Right. After that, let's apply this equation to the car. Can we apply velocity equal displacement divided by time taken for the car? Somebody please tell me. Can we apply velocity equal displacement divided by time taken for the car? Can or can't? Can't. Because car has an acceleration. So when an object moves with an acceleration, we cannot apply the velocity equal displacement divided by time taken. When an object is moving with an acceleration, we should use the equation S equals ut plus half at square. So x to y displacement is simple d. Starting velocity of the car is 0. Time taken we don't know. Plus half acceleration is 0.3. Time taken is t square. Then we will obtain simple d equals 0 times anything 0 plus 1. We can write it like this: half 0.3 can be written as 3 divided by 10 into t square. Right? So let me write one more step. Simple d equals 3 and 2 cannot be cancelled out. 2 times 10, 20. So we can write that 3 over 20. 2 times 10, 20 into t square is simple d. Let me take this as my second equation. So please write 1 and 2 equation. And if you have any doubt, you can unmute the mic and ask. Complete there.
Okay, sir.
Right, so let's use 1 and 2 equations together, and let's try to solve the 2 equations. Let's try to find the term simple t. Look at board here. Look at board. According to the equation number 1, simple d equals 12 times t. According to equation number 2, d equals this 3d square over 20. 3d square over 20. So both equations give the same simple d term. Same simple d term. So let me combine them. Right? So if we combine the 2 equations, we can write it like this. 3 times t square divided by 20 equals 12 times t. 12 times t. Right? If I take 20 to this side, I'll get I can take both 3 and 20 to this side by cross multiplication. Then I get t square equals 20 divided by 3 into 12 times t. So it means t square equals 20 times 12 divided by 3 is 4t. 4 times t. 12 divided by 3 is 4. So then we will get t square equals 4 times 20 is 80 times t. There are 2 methods to simplify, but I would like to follow the method that we used in pure maths to solve this equation. It's better if you know this result also. Let me take 80 times t to this side. T square minus 80 times t equals 0. T square can be written as t into t minus 80t equals 0. Now you should understand this simple t and this simple t common. Therefore, simple t can be taken out from a bracket. The remaining terms will be t is taken out. This time t will be there. This t is taken out. 80 will be there. Even from O levels, you know that this relationship, when the product is equal to 0, even from O levels, you know it. For example, let's say it's given that a times b equals 0. What will happen when a is 0? If a is 0, a times b equals a is 0, b. 0 into anything 0. What will happen if b is 0? A times b equals 0. A times b is 0. 0 into anything 0. So when a product is equal to 0, one of them must be equal to 0. That's the law. If a product is equal to 0, one of the terms should be equal to 0. So here we have a product. We have a product t into t minus a. So therefore one of them must be equal to 0. So we don't know which term is 0. So then we write t equals 0 or t minus 80 equals 0. So we got our first answer as t equals 0. The second answer is t equal minus 8 goes to the other side as positive 8. Now my question is, which answer is correct? T equals 0 or t equals 80? Somebody unmute the mic and tell me. Which answer is correct? Lamaya?
T equals 80.
Any other answers? Actually, this is one of the most beautiful thing in maths. T equals 0 also correct, because t equals 0 means starting point. At the starting point, both vehicles are at the same level. You see, both are at the same level. T equals 80 is also correct. After 80 seconds, both are at the same level. Can you understand? At t equals 0, that is the starting point. They are at the same place. After 80 seconds, they are at the same place, but having different velocities. Velocities may be different, but they are at the same place after 80 seconds. So that's the beauty of maths. Maths give you the complete idea. The whole story is given by maths. At the beginning, t equals 0, both vehicles at the same place x. After 80 seconds, both vehicles are at the same point y, same place y. So both answers are correct, but here we say the car will overtake van after 80 seconds. So please write this, please write both and write the car overtakes van after 80 seconds. The car overtakes van after 80 seconds. Complete here. Right, below this you should write that the car overtakes van after 80 seconds. Then only you will learn full marks. How do you find this velocity V1 dear? V1 is the velocity when the car reaches 2y. How do you find it dear? How do you find it? If you want, you can write this as a note, right? If you want, you can write this as a note. Somebody please tell me the method that can be used to find the velocity V1. Lamai?
Apply V equals U plus 80 to the car.
Very good. So to the car, let's apply to this direction V equals U plus 80. The velocity of the car, final velocity of the car is V1. Initial velocity of the car is 0. The time taken is 8. Time taken is 8. So V1 equals 0 plus A1 is 0.3. Time taken is 8. So 0 plus 0.3 can be written as 3 by 10. 0.3 can be written as 3 by 10 into 80. So this 0 and this 0 cancelled out. 0 plus 3 times 8. 3 times 8 is 24. The velocity is 24 meter per second. 24 meter per second. Got it? So it means velocity of the van is 12 meter per second. Velocity of car is 24 meter per second. It means car has double the velocity of the van. It means definitely car will overtake the van at the point Y. Complete the note here. And I think that's enough for today. If you have written everything, you can leave the class. Next week, we'll be able to start projectile motion, and that will be the end. You should write a short note, and I am going to start circular rotational motion so soon. Complete. Good luck. If you have written, you can leave the class. Good luck. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir. Thank you, sir.
Okay, dear. Good luck. Welcome. See you. Bye.